In this video, I'm going to be doing some solutions to the first semester review. The first problem here asks me how many 5-digit numbers end with 52. Okay, so I'm picking numbers basically, or sometimes these are like passwords or something. So there are 5 decisions that need to be made. This is really fundamental counting principle. I'm choosing things in this position and in this position and in that position and so on. And of course we know from all kinds of different application problems this year that and usually means we multiply. So we need 5-digit numbers to end with 52, which means I want to have a 5 in that next to last position. There's only one way I can do that. And I want to have 2 in the last position, and there's only one way I can do that. So not really a lot of choices there. Now the 5-digit number here, remember that the digits from 0 to 9, there are actually 10 digits between 0 and 9 if you count those up. So there are 10 possibilities I could have in this position here, 10 positions I could have in this position here. The last position, if you think about it, I believe the way the question is worded, this is implying that we don't want to have a 0 in the first position because, you know, I wouldn't view a number beginning with 0 as being a 5-digit number. So I believe we want the digits 1 through 9 in that last position. And that's going to be 9 times 10 times 10, which is going to be 900 possibilities. And that's our final answer. So I don't want to include 0 on that first one. All right. Number 2, the 7-member Jones family is sitting on a bench for a photo. How many arrangements can be created in which Mr. and Mrs. Jones are sitting either of the third and fourth positions? So it's another fundamental counting principle problem. I like to do these with blanks. There's 7 positions, and we're looking at position 3 and position 4. Now, there are 2 different people. It can be Mr. or Mrs. Jones sitting in those spots. So we have 2 ways that we could pick one of them to be in a spot, and then you're left with 1 way. So, you know, if you think about it, it's either Mr. Jones and Mrs. Jones or Mrs. Jones and Mr. Jones. It's 2 different ways. Now, after we've filled in the required values, we basically can fill in everything else. So there are 5 additional family members, 5 ways we can pick that first spot, 4 we can pick the next, 3, and then 2, and then 1. And I believe 5 factorial is 120, so it should be 120, well, it should be 5 factorial times 2, basically, which is going to be 120 times 2, which is going to be 240 different arrangements. And that's what we've got going on there. All right. Number 3, number of unique arrangements with the letters of the word Cincinnati. Cincinnati has 10 letters. If there were 10 different letters, it'd be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. It would be 10 factorial. However, there are 3 n's, and it means for any arrangement of all the other letters, there would be 3 times 2 times 1, 3 factorial different ways that we could arrange those n's that would read as exactly the same thing. And that's for each of the arrangements of the other letters. So 3 factorial is 6. So they're basically 6 times too many arrangements if we include all the different arrangements of the n's being different, because they're not. So we can divide by that factorial, and that repeats, or that eliminates that 6 times too many n's that we're having an issue with. And then we can do the same thing with other letters. So there are 3 i's, and there are 3 i's, and that's also going to be 3 factorial. And there are 2 c's, right? And so there are 2 factorial different ways that we can arrange the c's. And so we're going to end up with that value there. Now, if I'm putting this in a calculator, probably going to use the factorial button for the 10. Remember, you can go to math, and you can go to probability, and you've got a factorial option there. So there's our 10 factorial. 3 factorial is really just 6, so I would divide by 6, and I would divide by 6 again, and then 2 factorial is 2, and I would just divide by 2, and it looks like it's going to be 50,400 arrangements. All right, we can move on to number 4. Number 4, we have product codes using a combination of numbers and letters. How many unique codes can be created with 2 letters followed by 3 numbers? And it says that we have upper and lower case letters are considered to be different, okay? So it's 2 letters. So normally it would be 26 options. It says we can have repeats. So normally it would be 26 letters, but if you include uppercase and lowercase, there would actually be 52 if lowercase a and uppercase a are different, lowercase b and uppercase b and so on are different. There would be 52 things that you could have in the first position, 52 in the next. And then 3 numbers, and doesn't imply anything about 0 being a problem, so 10 options, 0 through 9 for each of those positions. And so 52 times 52 times 10 times 10 times 10 is going to be 2704 with 3 zeros at the end. So it looks like it's going to be about 2.7 million possibilities there. A lot of different possible passwords. All right, question number 5. Millie is selecting seating arrangements for a wedding, and how many orders can she seat 8 members of the family around a circular table? Well, I'm not going to reprove this right now, but we did develop this concept earlier in the year, and we found out that because everybody can get up and move 1 seat over, however many times, the number of people there are sitting around that table, it's actually the number of people or the number of items minus 1 factorial. So if it's 8 people around the table, it's 7 factorial. 7 factorial is equal to 5,040. So there are 5,040 different orders. All right. Number 6, and I think we'll stop here. Actually, I think I'm going to stop before this one. I'll do a different video with starting with number 6.